Welcome all. We'll continue class 11th of Python programming. I'm defining a simple function here, def, then name of the function fun, and then let me write a colon here, and then anything. Suppose I will write a is equal to 10, then let's proceed, and let me return b and do some task. Suppose b is equal to a plus 1. So here we return b and we define a. Okay, so we are not sending any value, but whenever you call a function, you have to write fun and bracket. At this point, I would like to say you something. If you are from math background, that's fine. Otherwise, you have to know x and f of x, they're different. X and f of x, they're different. So if you write only x, and if you write f of x, sorry, f and f of x, they're different. If you write f, we are talking about a function. If you write f of x, it's not a function, it's a value in the other set. Suppose you define a function from a to b, f of x is equal to x square, and you define from r to r, then it will be a real number. It will be a number. F of x is a number. F of x is not a function. If f of x is x square, okay, if I write f of x is x square, and then I will find f of 2, then f of 2 is not a function, right? F of 2 is a value. F of 2 is equal to 4 here, and it's a value. Even you will have value for f of 3. F of 3 is not function. So if you write f of x is function, it's wrong. Fx is function. If somehow you write this is a function, then it's wrong. It's wrong to say that f of x is a function. Remember, f is a function. Okay. Let me delete it. I didn't run it. Okay. Let me write directory here. So whatever variables you have defined and whatever functions you have defined, everything should be here. I didn't define a variable. So let me define 3 variables here. They will come to the global scope here. Suppose a is equal to 10, b is equal to 20, and the name of the function fun. Okay. So let me run this. I got some value, that's fine. I got in return because it returned the value. I call this function. In some IDs, you are supposed to write print, print, but here in Jupyter, you need not write anything, just write fun. You'll get the printout. Whatever you got in return, you are printing directly without explicitly writing the print statement. You are able to print. So here you see, I have a global variable a, I have a variable b, and then I have a function also. Now you run directory. See, a comes here, b comes here, fun also comes here. So don't worry about whatever else is there. You are learning now. Just see whatever variable you have defined, they enter to the global space or not. Now a is available. A is available, B is available, and your function is also available because we run it. So this A is different. Let me delete this one. Let me write this as X, then Y here. Even if I will write AB, this AB will not see here. See, I'm running it. Now check. A is available here, B is available here, and FU1 available here. So this is the function, and this is A, this is B. All are available here. How about this? X and Y. You check X and Y, they are not available, right? So that's how they are local to the function. See, X is not appearing here. X is nowhere present. X is nowhere present means X is not in the global, X is not listed in the global variable list. Not variable, global scope you can say, because functions are here as well. Now, suppose I make this way. Here I define another function, nested one, okay. Suppose the name is FUNN, and then here also I'll write something. Suppose M is equal to 40. And I have to call the function, right? So you make a function call, control will be transferred here. Then you will not be able to enter this function. So you are here, you return something. Before returning, I have to write function call, right? So you write FUNN this. Now, first, if you want to define like this will be executed. And then this line, then the control will go directly here, because it will not be able to enter the function. So it will come here. So there is a function call. Through function call, it will come here. Then again, it will not be able to enter the function. So you see, up to this you have defined, right? Function ends here. See the indentation. So now comes X and Y. Okay. X will be assigned 10, Y will be assigned 10 plus 1, 11. Then it will call this function. Okay. Here, suppose you want to print 40. Let me write print M. Okay. That work is done here. Then it comes, you run, it's fine. So we wanted to print M only. So we got the printout 40. And then we wanted to return B. What is B here? Okay. Return Y will write. $11, right? So some task we are doing here, some task we are doing here. That's all. At least we are printing and we are incrementing a number by 1. So this is over now. So I run this already, right? Then let me run this one. Now you check. A here, B here, FUN here, then no FUNN, right? So again, this function is not available. This function is not available here outside. Okay, so you write 5 functions. Only the first one will available. It's not that all functions will be listed. The first function will be listed, because everything, whatever variable you define, whatever functions you define, all are within this scope. So nothing will be available here. You get only the global variables and the global function you can say. Now let's go here. This is a function anyway. So the task we have this one. Then call the function. Okay, so I got 40 here. Now this gives me 40, right? Because I'm printing whatever variable I've defined that I wanted to print. I print it, I got it 40. That's fine. Now what I will do is, suppose I will save it in some variable, fun. Even if you want, I can save it, the function in fun. And now you can check here, or directly even we can write. We are not writing anything, okay? So let me write here 10 and you write m here, cut this one. So fun 10, okay? Remember, fun 10 is different, fun is different. fun 10 I'm keeping in A, fun I'm keeping in B. Now what you can do is, suppose I will try to, instead of fun 10, wrongly you wrote this one. Then you are not getting anything here. At least we can write return and get something. Still we are not getting anything. You have to write the value here. Suppose 20 I write. I got 20. When you don't write anything, okay, then there is a problem. When you write only fun, you run, you are not getting anything here. It shows that this is the function, and wherever it is, it's showing, okay, dot fun. I will talk more about this dot and all those things, don't worry. But remember, if you print this function, not print this one. If you print this, you will get 10. If you print the function, okay, suppose I don't want to print this, I want to print the function itself, not the functional value. So when you print this one, you are getting something, okay? And remember, you are getting in hexadecimal form. How can you check this is the function address or not? See, we have written A here. There is a ID. Another thing you need to remember in Python, it's different from other programming languages. Most of the other programming languages, even those who are learning Python for the first time, they are at a better position. Because when you see, when you define a variable, it is a meaning. Here variable is only a tag. The memory location is for 10. The memory address is for 10. A is only a tag here, nothing more than that. So here ID of A, when we write, A is the variable that is tagged to 10. A is pointing to 10. So it gives in the hexadecimal form. If you want to check, suppose I want to check the ID of AB, print, or directly we can write here ID of Instead of A and B, I will write FU1. If I write FU1, it will give the ID of the function. If I write ID of A, I will get the ID of A. See, this is ID of A, where A is stored. I mean, the number, this number 10 is stored in this address, number 10. The tag is A. A is pointing towards this number 10, whose ID is this. Not only the variable, I showed you in the global scope also, because function is also present in the global scope. Okay, it has a place and the ID is given. This ID and this ID. They are the memory location address, you can say. So now how can you check you got something here and something else here? Remember, there is a function called hex. Because you get in hexadecimal form, by chance you never come across hexadecimal number or you forgot hexadecimal number, you can always go and revise that. But here there is a easy function. I can write hex and I can check this one. So check one by one from the right hand side. The first one is A here, 8 here. The second one is A here. The third one is 3 here, then 9, 9, C, B, whatever you are marking here. The same also we are marking here. You check. It starts from this. These zeros we won't get, okay? And you get from here. Check these, they are the same. That means the memory address, if you directly write ID and if you find, or you print FU1, they are giving the memory. If you want to print FU1, the function, then you get the memory address here. That's all. But if you print function with some number, this is very, very important. You will see the use. We further use of this. That's why I'm repeating this one. So you get a value. However, if you run this function, you don't get a value. What you get is the memory location address in the hexadecimal form. We checked also, they're the same. Okay. Now, let me delete all, or do this way. Now, let me define a function fin. And A is equal to 10, then B is equal to 20. Then I want to add these two numbers. B is 20, some operation, right? And C is equal to A plus B. And then I want to return C here. Then I can write fin. You write this function will be called. That we know. 30. Now, let me give this number 10 here and write only B. Then you run this way. So 10 goes here and B is this one. A is 10. Okay, through this we are sending. And B is 20. And C is A plus B. Then you return C. So in return we got 30. That we know. Now what we can write here? We can write anything here. We can write a number. We can write a name here, we can write a tuple here, we can write a list here, anything if you want. Even dictionary also you can send here. If you don't know about dictionary, don't worry. In the next class, we'll do dictionary, tuple and sets. So coming to this one, you can you can put any object here. You can send any object here when you call this function fin. Now, when I say object, it could be a number, it could be a string, tuple, dictionary, sets, whatever. Not only those things I uttered, but also we can send a function here. Function within a function. How can you send a function here? Suppose I will write fun here. Where is fun? If it's defined before, definitely we can do that. Suppose I write fun and its work is it returns suppose x. If you call fun and you increment it by some number, suppose 10. Okay, whatever number you want, you increment it by 10. Here you add or you square it, whatever task. It is a task, right? This is a function, it is a task. So whatever number you write here, suppose you write 10 here, then you get 20 here. That number will be added by 10. And here it will be added by 20. And instead of writing a number here, okay, I've written already the function. So let me write a value here 20. So you know the meaning of font 20. Will not write at all here. Okay, forget about that. This is over. I can run this also. This will be fine. But fun will be called wherever there is a call like this. Okay. Of course, I have to write a variable here, whatever x I've written. So fun is called within fin. Okay. So actually you are calling this function, but the one you are sending to this function, the one you want to send, that is fin 20. So what will happen? Run it. You got 50. So what happens is I wanted to call this function. Now, if you tell me, please write the directory and check it. Both functions are there, fin, fun. Remember. So when I talk about fin function here, this is available. Fun are also available. Why they both are available? Because this function is separate. Okay. Then this function, there is no link. This function fun is a different function. Like we define variables a, b, c, we have defined two functions. If you make it a nested one, if you write this function within this function, then this will not appear. But if you remember, we discussed nested functions in the previous classes. It's not a nested function. That's why it's outside. These are considered two functions. That's why they appear in the global scope. That is one thing you need to note. The second one is you can send a function here, fun here. Not a problem. Now my question is, suppose you write fun, then what will happen? We already run that one. can I send FU1? That is the question. So if you send FU1, okay, FU1 will go to A, then you want to add A with B, but A is a function, A is not a value. How can you add with add B is 20 with the function? Can you add 20 with the function? Never, right? So can I do something here? Because FU1 goes to A, so A means FU1 here. A represents the function here. You can make a functional value. Can I write like this? Suppose I want to write the number here, 10 or 20, whatever we wrote last time. Here I will write. Will it work? Let me run it. It worked, right? So not only functional value, but also you can send a function here. Sending a functional value, sending a function, they are different. So when you are sending this function, here A represents this function. So when A is there, that means A is this function FU1, right? So instead of calling f of 10 here, you are not calling a function. Function call, see, function call is FU1 of x. That's function call. Here you are sending the function, that function is equal to A. And when A of 10 you write, that is equivalent to FU1 10. So you are making a function call here. So now the control will go here. And then 10 with a value 10 here, 10 will be added to 10, then you get 20 and you return 20. So where it will go? Because you sent from here, in return you collect here. Then add to B, then finally you get C. That way, finally you get the answer 40 here. Okay. We'll discuss factorial. How to find factorial of a number. How to find sum of 10 numbers. Suppose I write sum is equal to 10. Then I can write sum is equal to 0. Sum is equal to sum plus I. So obviously you need to write a for loop here for I in range 10, suppose. You write a colon here. So now sum is 0, new sum is sum plus I is 0, so sum is 0 once again. Then this will be 1, so you write 1 here. It will get incremented every time. Then if you write print sum here, it will look odd, right? You get all 0, 1, 3, 6, 10, 15, 21, 28, 36, 45, all you are getting. So what you can do is, instead of writing here, when you write print here, this is within for loop. So whatever number of times you are looping here, 0 to 9, 10 times. So 10 times you will get the print statement. 10 times you will get the print out, because you are executing 10 times. But you don't do that. The final one only we want. So you write here for loop within for loop, it's not there. Once it's over, whatever is the last value of sum, that will be printed here. 45, you can check, it will be 45. If you add 1 to 10, if you want to write, I can write a comment here to find sum of first 10 numbers or first 10 numbers. We can make it n numbers also. Suppose you write x here. Integer input Please enter a number. Please enter a number, and if you want, you can write a question mark also. This bracket is for this one, this bracket is for this. That's fine, because input statement, input function returns in strings. So you have to transfer to integer. You must be knowing that. And instead of 10, we'll write here x. Or you can make it n also, whatever it is. I hope it's fine. Okay. Please enter a number. Let me write 10 here. Enter here 45. Run once again. Please enter a number 5 here. Enter 10. If you add 1 to 5, you should get 10. Okay. Please enter a number here 20, 190. 20 into 21 divided by 2, right? So n into n plus 1 by 2, we are not getting. I think there was a problem before only. N into n minus 1, sorry. 19 into 10, 190, that's fine. Now we'll find the factorial. To find the sum of first numbers, to find the factorial of a number. Then you can write here factorial is equal to 1. It will start from 1. If you start from 0, then there is a problem. Then input that number, and you have to write factorial. You write FACT here and multiply this one. Three factorial. You got 0. Why? For I in range 3, factorial is 1. Okay, the first number is 0. You start from 1. Still there is a problem, right? Because it should go up to x plus 1. See, there are other ways. Even I don't remember I've done this before. There are so many ways. I'm saying you one way. Enter a number 5. 5 factorial, 120. Enter a number, suppose 4 here, 24. It's working. But if you put a number 1, 1, fine. 2, 2, fine. How about 0? Fortunately, 0 is also giving 1 here. That's fine. 0 factorial, we have to take 1. Otherwise, most of the time we write 0 factorial is equal to 1. Okay. So how you are getting 0 factorial 1? Factorial is 1 already. And when you write x0, then what happens? I in range 1 to 1. Yeah, I in range 1 to 1. Factorial is factorial into I. So 0 is not coming into picture at all. Even 1 to 1, I in range 1 to 1, that should create a problem. Yeah, because if you leave this one even, for I in range 1 to 1, print I. If you write 1 to 2, you got 1. 1 to 3, 1 to 1 to 1. Because 1 to 1 means you are not getting nothing, right? That's how. That one you got because that must have stored somewhere due to that, not from the range. Anyway, we have written the that one, and we were able to find the factorial of a number. Now, I want to find the factorial of a number using recursion. Okay, recursion is also very important. If you are not from math start background and you never came across this way, recursion is something. Suppose you write 5 factorial. This is also kind of recursion. Recursion means time and again the same thing will come in a different way. 5 factorial when you write, you can write 5 into 4 factorial, right? 5 into 4 factorial you can write. Again 4 factorial, you can write 5 into, here 4 factorial you can write 4 into 3 factorial. This is only recursion. So what will happen? You start with 5 factorial. 5 factorial is 1 into 2 into 3 into 4 into 5. Here 1, 2, 3, 4, 5. You have to multiply everything. So you write 5 here. Then you want to find 4 factorial. These 4 that will be here. Then 5 into 4 here, 4 factorial means 1, 2, 3, 4. You write up to 3, then 4 here. So that way, how can you find factorial of a number? 5 factorial, 6 factorial, whatever is given. That's what you need to do. So this is an alternative method I'm writing. But remember, if you don't know about factorial, you can always search and you can get it. You try to know what is a factorial, then try to understand whatever I'm writing. Yeah, it might work. You can write input a number, those things you can do yourself. I'm just trying here in one way. Okay. Print factorial, we have to give some number 5, suppose. So we are returning and we want to print. Okay. Yeah, there must be a problem. So when you want to do this, so there is a function called here, 5 will go here, and 5 into fact 4, there is a function called here, then again it will go here, then 4 will come here, that way. Finally, you come to, if you continue this way, fact 0. So fact 0 or 1, we have not written, that's the problem. That's why we are not getting. One number you have to know. Then only we'll be able to find. If you have any doubt, I can write this way. Suppose I write a recursive function, particularly for those who have less exposure to mathematics. Suppose I can write something this way. Suppose an I'm writing. This is a recursive function. What will happen is, suppose you want to find a3 or a4. A4 value will be equal to a3 plus 10. Then I can copy this. So this will give you a3. This is a very simple recursion. A2, A1. So if you know A1, this is called boundary value. In mathematics, we say boundary value, the value at the last point. If you know A1, then you can find A2 from A1, then A3 from A2, then A4 from A3. That way you can get A3. So if you don't know A1, even if you don't know A1, you know A0, then also it's fine. You have to know one value. Now suppose it's given here. Along with this, the boundary value is given A0 is equal to 50. Then you can solve this problem. Okay. This is a recursion problem with a boundary value. Here what will happen? If you want to find A4, you go on writing the same function many times till you go to A0. Put the value of A0 here, get A1, put A1 here, you get A2, put A2 here, you get A3, put A3 here, you get A4, that way. Similar way, if you want to find factorial here, so when it goes to 0 or 1, then what it will do? How it will know what is FACT 0 or 1? So you have to write a if else statement. Okay. Let me add that. Because we never find 0 factorial, let me write 1 here. Return 1. So factorial 5 is 120. You try with factorial 4. Now let's try to know why you are getting 24 when you run factorial 4, when you call the function with 4. So how it will happen is, you are calling this function. Actually, it starts from here. It will not be able to enter. So ultimately, these will be skipped. It will come here. Then there is a function call. Through this function call, it will go here. Control will go here. And n will be 4 here. Then they will be checked 4 is equal to 1 or not. Because 4 is not equal to 1, then it will come here, else statement. So else what will happen? Return 4 into, there is another function call here, fact3. So again, through this function call, it will go here. So see, this is not over. So for this, it has to go once again here. 3. Again, 3 will be compared to 1. They're not same. So it will come to else. So return, already you have 1. Already you have 4 into fact3. 4 multiplied by fact3. Already you have this. Okay. Now, again, there is a function call. Through this function call, you go here, then check 3 with 1, they're not equal. So you are coming here. So then you have to write 3 into 3 multiplied by fact 2. Then 2 here. So no work is finished by now. Okay. The last function call will be fact 1 here. So how many times you are calling a function, you see with this function call, now 1 is here, then 1 is equal to 1, it will return 1. It will return 1 means this function call, this is a function call, this is a function call. So here you call the function and you got 1. Then this one copy with, you had a function call here. There you have to write this one. This will come in return. Now there was a function call, this one, that will come here. Now this one you have to return. So that is nothing but 4 factorial 24. Yeah, that's all for today. We'll see once again in the next class. We'll do more. Thank you.